This is a basic demonstration of our DICOM routing product, which we call Ultra Archive Plus, although there's also a version of it called Ultra Gateway. We also have Ultra Gateway High Volume, but they all basically look the same. It's what you see on my screen here, the application in the middle of the screen. So when you set up an Ultra Gateway, you basically, this is the most important screen here where you have your auto routing, outgoing and incoming. So typically you'll have incoming nodes. Outgoing nodes are places that you can send to. So for example, I can call this store SCP. I'll give it an IP address, a title. So all the basic stuff that most of us are used to setting up for DICOM nodes. You can bind your outgoing nodes to a MAC address if you need to. For example, you can set a format. Do you want it to send JPEG, JPEG 2000, and so forth and so on. You can set a priority. You can turn on encryption. So lots of different options here for setting up your DICOM nodes. And then as far as auto routing, so if you have incoming nodes and outgoing nodes, you probably want to auto route from incoming to outgoing. So you can define those rules here. I'll just call this rule test. Usually the trigger would be something like image received, or it could be image saved, and there's different types of triggers. You can trigger based on where it came from, or you could just say trigger the rule on everything. You can do timing. So when you turn on your timing rules, you can route the studies during certain times of the day, or certain days of the week. With your rules, you can basically with the rules you can set up routing rules based on any DICOM tag. Well, not any DICOM tag, but any tag that we support in our software, which is the vast majority of them. But you can basically type in any DICOM tag. You can use different operators. In other words, is it equal to, greater than, less than? Does it contain a certain value? So, for example, you could say, does my study contain a body part of head, and it has to be, say, an MR or a CT or something like that. So you can combine different logical operators together to create these very complex rules based on things that are in the DICOM header. And then once you do all that, then you tell it where you want it to route based on the rule. You can set the format, the priority. You can send it immediately, or you can put a delay on it, so you can have it send at night or something like that. Although most cases you probably want it to send right away. We do support DICOM TLS, so you can do encryption if you want to. And of course, so you can combine encryption and compression, so it can be compressed, it can be, all that stuff. So this is how you set up the routing rules in our gateway product. But one of the disadvantages of setting up routing rules this way is that the study would have to be received completely first before it routes. So in order to parse that routing rule, those more complex routing rules completely, when an association is opened, so let's say a large CT is being sent to us, and the CT had 5,000 images in it. The association is open from the modality. All 5,000 images would be sent to us. We would process all 5,000 and then begin routing those once we've processed them, which can add considerable latency to routing. So to work around that, or to sort of make the routing a little bit faster, we have real-time routing. So the real-time routing, I'll show you how we configure that. If I go into my into this other dialog box, so I still have my incoming nodes, so they're still here, although they're incoming and outgoing in this interface, but these are my nodes. So basically in this scenario, I'm going to route from store SCU to store SCP. So I have a command line window running over here, which is going to be my sender. I have another command line window over here, which is going to be my receiver. So we're going to get to see the data being sent from one to the other, going through the DICOM router. So, and how do I set up that routing? So if I go into store SCU, which is the from side, so that's the one on the left, this is my node from the left. When I look at my routing tab, I have the option to route from list. So I'm basically saying anytime I receive something from this node, I'm going to check this little box down here that says route it to this node, store SCP. So it's very basic routing. You can do some limited conditions. So we have some options here to do some conditions, and you can route by certain attributes. So you can certainly do some routing logic, but not a lot. So it doesn't have as many options as the non-real-time routing, which I showed you earlier. So once you go in here and you set up your routing rule, and let's Go over here to one more dialog. So this is where we turn on our routing. So our product can support up to 32 concurrent routing threads, which means even though we're receiving the study perhaps on one thread on one side, we can multi-thread those when we route them. And by the way, we can also support multi-threaded receiving and routing. So you can have up to, actually I think there really is no limit on the receiving threads other than the limits in the operating system. So you can have a lot of threads coming in on the inbound side, and we'll open up to 64 threads on the outbound side when we're sending the DICOM traffic. In my little example here, though, I'm just going to set this to one routing thread because Store SCP only supports one thread, so really no use having more than that. But you could certainly have, again, up to 64. I think it's 32, sorry, 32 threads for your routing. So I'm going to set mine to 1. So now the way I have this configured, when I start sending data from this system on the left, I should immediately start seeing data being received on the system on the right. There should be no delay in the routing from one to the other. So most DICOM routers have some delay in that, but you're going to see here that there is no delay. It's going to start routing in real time. And if I had multiple Store SCPs running multi-threaded, we could see that stuff multi-threading to the other one, which makes it even faster. So let's go ahead and do that. And by the way, the other thing I'm going to show you too is we'll go in here and show service information. So this will actually show us that it's routing. So down here you'll see these routing threads. I only have one active thread, so you can see here it's showing that it's really not doing anything right now. But if I go over here to the left side, let's do on the, well, I'll do the right side first. So I'm going to start the listener. So the listener is now running on the right side. On the left side, I'm going to run this command, which is basically going to try to send a whole bunch of images that are in that directory. And like I said, as soon as this one starts, you can see over here, this one's already receiving. And you can see here that it's working its way through those images. So it'll very quickly get through those 19, and already there's going to be more stuff in the queue. So there you can see now it's up to 51. So it's going to continue routing. So we can get to see, we can see that traffic routing in real time from the left side to the right side. So if these were, CT images, and there were thousands of images in these CTs, there would be very low latency in the routing going through this routing product. But you still have the advantage of being able to bifurcate that DICOM traffic to two, or even to send it to many different DICOM nodes on the other side, and still use some of those rule sets. So you can see it's still routing. So this will go for a little while. While this is running, I'm also going to show you, so we have some pretty in-depth logging that you can do on the product. If I go into my TCP logs, so I'm going to go into my TCP logs, and I should be able to see, let me just, sorry, I had to pause the video for just a moment. There was a loud train going by, but I opened up a log for you. So this is what the TCP logs look like. The nice thing about these logs is they're very detailed. So you can kind of see here, you can see exactly how long it's taking to route each image. So this is a CStore request is trying to send the image, and then you get the response here after the image has been sent. You can see most of these are sending in far less than a second. And I can scroll down so you can see that this whole study, you can kind of see how long it took. It took a little under a minute to route the study. It was a CT. And when I click on any one of these CStore requests, you can see the details. So it shows you everything about that study. So you get a lot of information in here. And you can even get to an even lower level to see the actual DICOM chatter. So you can see here, now I can actually look at the PDUs. I can look at the packets. So I could double click, and these are the actual packets. So it allows you to do some really granular troubleshooting when needed. This is a DICOM routing product. It's all about DICOM integration, and in many cases we are interfacing to systems maybe that don't have very robust logging. So we have to do a tremendous amount of logging so that we know exactly what's going on both sides to make sure everything's working right. So in any event, this is how the routing basically works. So it's very low latency real-time routing, but with the low latency real-time routing, you have slightly fewer options on the routing. However, if you do need those more granular routing rules that I showed you earlier, we can actually configure real-time routing with these granular routing rules that I showed you, where it's a little bit more user-friendly to create more complicated rules that combine some if-then, more complicated logic rather. So it is possible to do that, and it's certainly something that we could chat about if that's something you're interested in. But out of the box, the product does everything that I showed you, where we routed from the side on the left to the one on the right with low latency. These were CT images. These were actually compressed JPEG 2000 lossless images, but we can certainly support lots of different types of compression or even uncompressed images. And you can even convert to compressed. So we could receive it as uncompressed, and we can be compressing it as we send it, or the other way around. It can be received compressed, and then we can uncompress it on the outbound side, all depending on what the different systems support. If you have any questions, please let us know. Thank you for watching.